Hi, welcome to lesson number 2, module 5 of the Apache Spark and Scala course. So in this particular lesson, we will be diving deep into the Spark SQL architecture. Now before we proceed, let's have a quick look at the last lesson that we have learned. So in the last lesson, we introduced the Spark SQL library. We had a look at a brief history of the Spark SQL project, and we understood that it has evolved from the original Shark project. We also came to know the advantages of using Spark SQL, a comparison with Hive, and some of the unique features. So in this lesson, we will understand the Spark SQL library, the core architecture, and where exactly it fits in the Hadoop ecosystem. Now, if you look at the Spark SQL library from a 10,000 feet overview, it will look like this. So basically, there are 4 major components in here. You have a data source API, then you have a data frame API, and there is a SQL interpreter and a SQL service. Now let's look into these components in depth and understand their functionality. Now, if you look at an overall architecture of Spark SQL, you can fairly understand that the first problem that we are going to deal with is to access the data. Now, whatever SQL query you want to run, you should have the data first. That means the Spark SQL library should have a very strong method to access data from different sources. And the bottom layer in your Spark SQL architecture is the data access layer, which can access multiple types of data and from multiple formats. This is achieved by the data source API. So here in this picture, you can see that the data source API can read JSON data, CSV data, JDBC data, Parquet data, so on and so forth. So basically, it can comprehend any structured or semi-structured data. And on top of the data source API, you have the data frame API. So once the data source API reads the data and then interprets the data frame API gives a table-like projection to the data so that you can run your SQL queries. Now, to go in depth, the data source API is built by keeping one thing in mind, that Spark SQL should be able to read almost any types of file formats from any place. So it's a universal API and it supports Hive, JDBC, HDFS, and Parquet. It even supports external data sources using Spark package, and you can even have a third-party integration. So especially when you are working with certain types of file formats, even for CSV files, you can include a Databricks library, and using the Databricks library or package, it can specifically read most of the CSV types. Now let's look at an example, and don't worry if you don't understand it right now, because we will be seeing these examples as we go along with the hands-on. Now there is an object called SQL context that is created and used to access the Spark SQL libraries. And the function that we will be using is SQL context.load. Now if you want CSV file, you can say CSV data source .scala, or you can say JSON data source.scala for JSON files. Now let's look at the data frame API. So basically, the data frame API's job is to give a table-like structure to the data that you have read so that you can access the data using 4 commonly used programming languages: Scala, Java, Python, and R. And a data frame is nothing but a collection of row objects in named columns. And you can even convert a data frame into RDDs. And you can think about a data frame very similar to a table. And you can create a data frame from either an existing RDD or structured data files or semi-structured data files such as JSON and XML from Hive tables or even from external databases. Now, the next components are the SQL interpreter and optimizer. Well, that is the next component. Now, the SQL interpreter and optimizer uses a custom Catalyst optimizer, which is built from ground up to optimize all your SQL queries. Now, the Catalyst optimizer actually uses the functional programming constructed in Scala. Now, it creates transforming trees, and it can perform analysis, evaluation, optimization, planning, and runtime code spawning. Now, the interpreter and the Catalyst optimizer are used to reduce the cost and run your queries faster. Now, some of the features of the interpreter and optimizer are the transformations are actually on a tree format, and this is indeed faster than the RDD, and it actually follows the functional paradigm, and any size of data can be processed. The last component of our Spark SQL library is called SQL Service. Now, the SQL Service is basically the entry point for working with structured data, and we will see this when we start the hands-on. The SQL Service is used to fetch the result from the interpreted and optimized data, which is coming from Optimizer. So that means using the SQL Service, you can run queries and collect the data as well. So to summarize, we can understand that Spark SQL fits just on top of the core Apache Spark libraries. This also means that whatever you are doing on Spark SQL as data frames will be internally converted into RDDs and executed by your Spark core. So to wrap up in this particular lesson, we have learned about Spark SQL library, the architecture, and where exactly Spark SQL fits in the Spark ecosystem. That's all for this lesson.
If you have any questions, please do not hesitate to raise a support ticket. Thank you.